video, we are going to learn about gradient descent. Before we understand the mathematical part of gradient descent, let's do a thought experiment. Now, consider that you are this person standing on top of a mountain. You have to get down from the mountain. How would you do that? By taking small step towards the descent. Here comes the catch in the problem. You are blindfolded. You do not know which path leads to a descent or which path leads to elevation. So now how will you decide whether you are descending or you are climbing? You are going to use your leg to find whether it is a sloping area or it is an upward sloping area. Now, in gradient descent, we have a loss function. In my previous video of linear regression, I have explained the loss function as the error function, which is nothing but the difference between the actual values and the predicted values. So over here, getting down from the mountain is just like minimizing that error function. That is minimizing the difference between the actual values and predicted values. There is one more catch in this case. It's that the moment you make an upward elevation, you are going to be penalized. You will be penalized by -1. And the best part is that whenever you make a downward descent, you will be rewarded with +1. This is the idea of gradient descent. Basically, you are trying to optimize the cost function of a linear regression problem. We can apply this gradient descent in deep learning problems as well. Now, let us formally define what exactly is gradient descent. Gradient descent is an optimization algorithm used to find the values of parameters. We have studied that we have two parameters. We have the slope and we have the intercept. Gradient descent tries to find an optimization algorithm which helps us to find the values of our slope and intercept in such a way that the values of slope and intercept that we have found minimizes the cost function. Now you would be wondering what exactly is optimization. Optimization refers to the task of minimizing or maximizing an objective function parameterized by x. Basically, it's an idea of minimizing or maximizing an objective function. Here, our objective function is nothing but our error or our cost function. Now, what is the objective of gradient descent? The objective of gradient descent is to find the global minimum of the objective function. Objective function is our cost function. This is feasible if the objective function is convex, that is any local minimum is global minimum. So we have already learned about convex functions and non-convex function. A convex function looks something like this, and it is easy to find the minimum over here. The local minima is only the global minima in this case, but in non-convex function that's not the case. Over here the local minima would be at this point, but the global minima would be at this point. So a non-convex function, it is not easy to reach the global minimum, but in a convex function you are able to reach the global minimum easily. Now we have to learn about derivative. A derivative is a term that comes from calculus and it is calculated as the slope of the graph at a particular point. The slope is described by drawing a tangent line to the graph at that point. Basically, we have learned derivative in our class 12. It is nothing but the slope. How do we find the slope? By drawing a tangent to our curve. Now, let us understand why this derivative is important. To explain derivative in a different way, it is also your learning rate. Now, what exactly is learning rate? We will see in a while. So our cost function is error, which is nothing but y predicted minus y actual. Now here we have three instances. What is our primary objective? Our primary objective is to reach the minimum. How do we reach the minimum depends on how do we take the steps. If we take very small steps, then what happens? It takes a long time to reach the minimum point. So the first graph that you see over here, we are taking very small steps. Therefore, it takes a longer time to reach the minimum point. In the middle graph, we are taking perfect steps to reach the minimum point. It's not taking too long, it's not like taking too short, it is taking optimal amount of time to reach the minimum point. But if you look at the third graph, you are taking such a long step that you are missing the minimum point. So too large of a learning rate causes drastic updates which lead to divergent behavior. So if you take a small step, you will take a long time to reach the minimum. If you take just right amount of steps, you will reach the minimum at the earliest. If you take large step, you will miss the minimum point. I hope the idea of gradient descent, the thought experiment that we have done, the concept of learning rate, whether we have to take a small step, large step or a medium step is clear for one and all.